You're watching The New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
Hello, everyone, and welcome to another episode of the New Stack Makers. I'm your host, Heather Joslin, editor-in-chief of the New Stack. And today we're going to talk about some of the challenges that emerge when you adopt AI in your organization. You're training models, you're running AI workloads, so on and so forth, and you may be coming up against some new concerns, such as concerns revolving around your infrastructure. What are those new concerns? What are some of the ways organizations solve them? What role does Inference play in how you provide infrastructure, and who's going to be maintaining that infrastructure that AI requires as time goes on? Joining us today to unpack all of this is Sid Sheth, founder and CEO of D-Matrix. Hi, Sid.
Hey, Heather. How's it going?
Very well, thanks. Thanks for joining us. Sid and I met at the first ever HumanX conference in March of this year. I'll likely reference our earlier conversation during this one. Sid, can you tell us a little bit about D-Matrix and what it does?
Sure. And first of all, thanks for having me. So D-Matrix is an inference compute company, and our focus is to build inference computing solutions for generative AI workloads, and specifically with an emphasis on extremely fast or ultra fast inference, but with an aim to make inference commercially viable for anyone who wants to use it. That has been kind of a foundational tenet for the company when we started it. When we started in 2019, our entire emphasis was to focus on inference compute. At D-Matrix, we don't focus on pre-training workloads. We don't focus on any other kind of HPC or graphics type of workloads. We strictly focus on inference compute, and our thesis and bet back in 2019 was that inference computing would go on to become the largest computing workload of our time, and that's kind of how it's playing out. And we've been fortunate that this is moving very quickly, and D-Matrix is really out to solve that specific problem for a multitude of customers.
Okay, well, that's thank you for telling us a bit about your company, and let's get started. My understanding of inference in AI, and please correct me if I'm wrong, is that it is when a model takes data and uses it to solve a problem or complete a task. Is that basically correct, or
Yeah,
how would
it
you
is.
define it?
No, it is correct. I mean, I like to typically always give my favorite analogy when I get this question. So if I may talk about that a little bit, but it's not very different
Sure.
from what we human beings do when we get ourselves educated and apply the knowledge we acquire in the workforce. Right? We spend the first 20 years of our life, going to school or college, and educating ourselves and acquiring knowledge. Sometimes we pay a lot of money to acquire that knowledge, but then we spend the next 40 years of our life really putting that knowledge to use and work, and essentially monetize all the skills and knowledge that we have acquired in the first 20 to 25 years, right?
Mm-hmm.
It's not that our learning stops when we apply our knowledge. We are learning and fine-tuning specific areas. We become domain experts in certain things that we do,
Mm-hmm.
and we keep learning in those specific areas. But the general kind of broader skill acquisition and knowledge acquisition no longer applies once you leave school and college, right? So it's not very different for AI. Pre-training is essentially the general acquisition of skills and knowledge for the AI workload or AI model. And then once you deploy the model, which is inference, you're essentially monetizing all that knowledge that has been acquired. And in some cases, you need to fine-tune a model for a specific area of expertise. But you don't really kind of have to retrain or pre-train the model like you did, for general skill acquisition, right?
Yeah.
So in that sense, inference is really very similar to us human beings, joining the workforce and applying our knowledge and monetizing it. And obviously, logically speaking, inference would be the much bigger opportunity compared to training. Very similar to us human beings, we spend more time working than acquiring knowledge.
And that additional knowledge, I mean, when you don't retrain the whole model, you're adding it. That's, for example, RAG, retrieval augmented generation.
Yeah, I
Yeah.
mean that's exactly, you have that as an option, and very similar to us again, right? In the workforce, if you don't know something about a specific area of we don't have expertise in a specific area, we always have access to the World Wide Web, or we have access to other sources of information, and we can always go acquire that knowledge or
Hmm.
tap into that. But we don't have to learn everything, right?
Right.
RAG is very similar. If the model is not trained on specific information it needs access to, then it can always tap into a RAG database to to acquire that knowledge.
So, what are some of the challenges that inference poses for organizations in terms of performance, cost, efficiency, you name it? What are some of the challenges?
Yeah, I think a lot of the challenges today are around essentially a couple of things. I would say it's actually more software focused and specific. The challenges, how do you really introduce a lot of these capable models into software workflows, right?
Mhm,
And then what is the killer app or the user interface that typical enterprise users would use to actually tap into those software workflows,
mhm,
right? So that's, I think, what is probably holding back adoption of broad-based inference in the enterprise market. If you look at the way inference is done today, you obviously have tools like Copilot, and there's Agent Force from Salesforce, and there's quite a few of these tools out there that they've already introduced AI into their workflows, but we still haven't gotten to the tipping point, right, where there is broad-based adoption of these, not just these tools, but other software and SaaS tools with AI. And one of the reasons is probably because, first of all, a lot of retraining is required in the workforce. The
mhm,
workforce in general needs to become very comfortable, in terms of how they use these tools. I think there is still a lot of human intervention required in terms of how these tools get used. So, if you want to accomplish something, you got to prompt, these models, and if you don't prompt it right, you may not get the result you want, and you got to reprompt it, and kind of iterate with the model to get to the outcome you want. A lot of that will change once agents come into the workforce, and with the promise of agentic AI is you can really describe a task at a very high level,
mhm,
and in simple English, and the agents are smart enough to break down that task and understand the intent of the user, and not just one agent, but these agents could work across silos in the organization, across multiple different tools, and essentially come back with an outcome that the user is looking for, right? So it's like almost like a team of agents working and collaborating together to solve a task. Now when you get into that world, obviously you're going to need a lot more compute, and
mhm.
that's where dmatrix comes in, because the cost of compute is going to spiral up, the cost of inference compute is going to spiral up as you start introducing agentic workflows into these organizations, and latency clearly becomes very, very important, because now it's not humans talking to machines, it's machines talking to machines,
Mhm.
and you want really quick response times, you want a quick turnaround time on the questions you're posing these agents. So latency is going to matter, ultra fast inference is going to matter, right? And that is
Mhm.
exactly the problem dmatrix is solving for, where we are able to support multiple users using these agentic workflows, why without sacrificing the latency per user. So typically what happens is, as you start batching multiple users, in the case of agents it could be batching multiple agents, right? What happens is your latency tends to suffer, because as more
Mhm.
people start using the application, each user is not getting as much time with the application, so their individual experience begins to suffer. We have found a way to essentially serve multiple users without sacrificing that uh, independent latency or per user latency, which allows for a highly optimized agentic experience when agents kind of truly enter the enterprise.
And I wanna dig down a little more into what D-Matrix does, but, I just want to get a sense from you of why you feel, do you feel that a different kind of infrastructure is needed for inference as opposed to training, um, in AI? Um
Absolutely, absolutely. I think I would argue that there is general consensus now that that will happen.
Mhm,
The world of inference, if you look at the world of pre-training, it has been kind of monolithic, right? GPUs have dominated, specifically GPUs from one company have dominated the landscape. But as you enter the world of inference, it is not really a one size fits all. There are too many different workloads, each workload with very different requirements. User profiles are very different, right? I mean, you might be a user who cares all about cost. There might be some user who cares all about interactivity, where I really want to be able to interact with the model. That's the latency part I talked about.
Mhm.
There might be users who don't really care about either and just care about throughput and batching a lot of data and gathering summaries from all of that data, right? So I think there's just different profiles that users bring to inferencing workloads, right? And not it's not like the same hardware or the same computing infrastructure can serve all these needs simultaneously, right? So
Mhm.
I think in our belief, the world of inference is going to be truly heterogeneous, where you'll have dedicated best in class hardware to serve specific needs from specific users.
When we met at HumanX, we taught you spoke to me about the connection between distance and latency. How does that apply in handling AI workloads?
I believe when I was talking about distance, I was probably talking about the distance, for the data. The data has to travel to get to the compute, um,
Right.
right? And one of the key challenges with inference compute is really about keeping the memory where the data resides
Mhm.
as close to the compute as you can possibly keep it. And the reason for that is you are kind of making a lot of trips to memory. When you talk about generative AI workloads, you're generating content that relies on caching data. So all the previous data gets cached,
Mhm.
and every time you generate a new token, you are essentially kind of tapping into that cache data to figure out what the next best token needs to be. And now just take that problem in an agentic world, that problem gets multiplied, 10x or 100x, right? So the memory footprint becomes very, very important, and keeping that memory close to compute becomes very important, right? So the less distance the data has to travel to get to the compute, the faster your inference is going to be,
Mhm.
and the more optimal your inference is going to be, the lower cost your inference is going to be, and all that good stuff. And that is what dmatrix is solved for. Is essentially we have created a platform that from the grounds up co-locates compute and memory very close to each other. So this way data has to travel a very short distance. In some cases it is actually physically co-located with the compute, so it doesn't have to travel at all.
Mhm.
And that is where all the energy efficiency, all the cost efficiency, all the latency advantages that we provide come from.
For those members of our audience who are watching this on video, I remember when we spoke, you took my phone and used your phone to show sort of
Right.
almost like a pancake kind of
Yeah.
situation with the.
Right.
Can you? So that's.
Yeah.
Can you elaborate on
Yeah,
that
yeah, sure. So
idea?
I think absolutely, and that is one of the key tenets again of the dmatrix platform. We built our platform with chiplets, which are smaller chips. We don't build big monolithic chips. We build smaller chiplets, as they're called, and then
Mhm.
we co-package these chiplets into a fabric, and that gives us that elasticity and modularity in the platform. We can always scale it up or scale it down depending
Mhm.
on the customer's requirements. And what that chiplet-based architecture allows us to do is what I talked about when we met at HumanX, which is there's different ways of packaging those chiplets. So you have compute chiplets, you have memory chiplets, and the traditional architectures today, actually pretty much all the traditional architectures today, the way they're packaged is you'll have the memory, say this is the memory, this is the compute, and you'll essentially kind of try to keep compute and memory as close together, right? So you kind of keep these two things very close, you abut them, and you co-package them on the same, what they call, say, common substrate, and they're kept together. In our case, what we did was we said, instead of doing that, why don't we just kind of overlay the memory directly on top of compute? So do a 3D stacking as opposed to a
Mhm.
2D, go 3D. And now the memory is sitting directly on top of the compute, and you're effectively, the data is sitting inside this memory and is raining down
Mhm.
into the compute, which is sitting right underneath it, right? So now, obviously, the surface area is much greater when you package things this way. Obviously,
Mhm.
there is more surface area between the memory and the compute, and a lot more data can drop down into the compute.
Mhm.
And it is physically, because it is co-packaged this way, it is physically like right next to the compute. So the data doesn't have to travel that much distance at all. And and then we can replicate this. So this could be one pair of chiplets, and there could be similar many instances of this that we can sprinkle through the platform. And that is where the advantage comes from in terms of how we are able to quickly access data from memory, and compute is always kept fully utilized. There's never a point where our compute is running idle waiting for the data to show up, right? Here the data is always available, so that's where a lot of those efficiencies come from.
And just for those who might be only listening to the audio, what Sid did was to show the way in which compute and memory are packaged. He put his palms side by side, and to show what D-Matrix does, put your hands together with the palms touching,
Right.
facing each other.
Facing each other, yeah, so it's like in a 3D stacked, like one hand on top of the other, if you can visualize it, right? And memory is on top, compute is at the bottom. It's a traditional 3D stacking architecture, where you can, HBM, by the way, HBM memory, which is very popular in pretty much all the GPU architectures, they
Mhm,
already do that, but they only stack memory on top of memory, right?
mhm.
In our case, we brought that stack of memory directly on top of compute. So if
Yep.
that helps your audience visualize it a little better, we take away the distance that has to be traveled from that HBM stack to the compute and back.
Mhm.
Instead, we just put it directly on top of the compute, so it can rain down into the compute.
What do you, who did, what kind of organizations or customers do you think might be the best use cases for this solution as things stand now?
Oh, it's everyone in the world who wants to use generative AI inference and wants really fast generative AI inference. So it would be pretty much all the enterprises, all the big clouds who serve those enterprises, all the neo clouds who serve enterprises, even the sovereigns, who care a lot about highly interactive inference. And highly interactive inference in general is becoming popular everywhere. And the reason
Mhm,
for that is very simple. Um, I think it's pretty obvious to everyone that when users use an application, the faster the application responds back to the user, the more likely the user is to stay with the application, right? If the whole experience is a very offline experience where the user has to work with the application takes minutes, maybe multiple tens of minutes to respond. Very
mhm,
unlikely that the user stays with that application. They'll go do something else in the meantime, right? So this ultra fast inference is becoming a very important ask from pretty much all our customers who want to essentially provide their users with a highly interactive experience so that they stay with the application that they're building. So
mhm.
I think this is anyone who's using generative AI across the planet, and so I think what we are doing here at D-Matrix is very relevant to multitude of customers all over the world.
We've been writing a lot lately about the new infrastructure that AI requires, and one question we've been grappling with is who will be maintain this new AI infrastructure? Will it require new roles, new skills? What do you see ahead for organizations that are investing in AI specific infrastructure?
Yeah, I mean, there's going to be a retooling and a reskilling that is going to be needed. The AI infrastructure is, I mean, obviously, the general purpose computing infrastructure that has served us for the last 20 odd years, 20 plus years in the cloud, right, is going
Mhm,
through a massive upgrade as you essentially are augmenting that infrastructure, in some cases, replacing that infrastructure with accelerated computing infrastructure. So it's starting with GPUs today, and over time, as I was stating earlier, it'll go heterogeneous, and there'll be other forms of accelerators and other forms of compute that will be incorporated into those fleets,
mhm,
right? And you know Typically the accelerated computing fleets, there is you know there's a different set of requirements in that they are highly performance oriented, highly efficiency oriented, depending on which type of application you're trying to solve. There's a lot of orchestration that you have to do at the data center level, because if your fleet is truly heterogeneous and there's different accelerators, you're trying to figure out in real time, as users are sending queries to that infrastructure, which queries need to be routed to which part of the fleet. And again, the fleet may not entirely be local, right? The fleet could
mhm,
be distributed across the globe. You might have to, in some cases, route queries to a fleet which is sitting maybe many many thousands of miles away.
mhm.
If the request is not necessarily a latency optimized request, it is more somebody is just looking to energy optimize, right? If there is a data
Right.
center that is sitting close to a very efficient and cheap energy source, you might want to route some of those queries there. So there's a lot of orchestration and software that will come in terms of how you serve the users and serve these queries in real time, right? So I think
Mhm.
there's going to be a lot of retooling and reskilling at the infra layer. I would not expect uh, that it's an entirely a new set of people that have to come in here. It is the existing folks that have to reskill and retool, and they can do it. I think it's starting with the hyperscalers because they have a lot of that expertise in house.
Mhm.
But very quickly, there's folks in the neo clouds and sovereigns that are acquiring those same skills as GPU infrastructure proliferates into those setups, right? And we'll be beneficiaries. Companies like D-Matrix who are not in the first wave will come as a follow-on. Will be beneficiaries of that retooling that is already happening and the reskilling that is already happening.
And one last question: what's on the roadmap for D-Matrix for the rest of the year, the next few months? Any hints you can drop for what to expect?
Yeah. I mean, nothing that I haven't already said. A couple of things that we are really focused on is quickly, releasing our product that we talked about, the 3D capability product. So that is really what the company wants to get out into the market quickly. Our current product is already out in the market.
Mhm.
Maybe I don't know if there'll be a video for your users, but this is
Oh, yeah.
the accelerator card. This is our first gen product, which is a PCIe card. It's rated at 600 watts, so it can go into a lot of the existing AI infrastructure that is already out there. And you can see these two chips here. If you pop the lid on one of these chips, there'll be four chiplets sitting inside each of these. So there's a total of 8 chiplets. And then what we do is we package that into what we call an accelerator unit, which looks like this. And this has two of those cards, the ones that I just showed you. So there's two of those sitting here, and then they're bridged with what we call kind of a DMX. We call it a DMX bridge that bridges these two cards together. That allows any chiplet on any card to talk to any other chiplet. So they're connected in an all-to-all configuration. So from a software perspective, the software treats this as a single unit. It's not treated as two distinct units. It's treated as a single unit. And this is what we ship to customers, and it's shipping to customers today and would plug into server infrastructure out there. So this product is already out there, and this is not currently a 3D product, right? It is a product that is planar. It's just got that
Mhm.
first level. The next product that we're going to put out is going to have the 3D stacking. So then we start building what we call the skyscraper. We'll put the first floor in, then we'll put multiple floors in, and keep increasing capacity that way. And the reason we are doing that is we are very excited about what's happening with reasoning, or what is called inference time compute, or test time compute,
Mhm.
which is where models are beginning to think more, and that is what feeds directly into the agentic era, right? Agentic workflows and agents will be using those reasoning models to think more, as opposed to just training models with more data, and more thinking equals more inference.
Mhm.
And so we are kind of, as a company, very excited about that future, which is coming in the next few years, and making sure that we are ready to serve that future.
Excellent. Well, that sounds. And when does that 3D project or 3D product, 3D product, um, due to hit the market?
Yeah, we'll be announcing something pretty shortly here in the next few months. Where we'll be demoing capability with that technology, and then the product will be out, a year later.
Excellent. Well, that sounds like a great place to wrap up. I want to thank Sid Sheth of D-Matrix for joining us today. Thank you, Sid.
Thank you so much for having me. It was a wonderful conversation.
Great. And I want to thank all of you for joining our conversation, and we hope to see you again soon. This has been Heather Joslin for the New Stack Makers, and we'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.